In lesson 6.1, we learned how to solve linear systems of equations. Now, in lesson 6.2, we're going to learn what happens when the system is no longer linear. That means when we start including exponents different than 1 to our variables. And the process is very, very similar to the process we learned before. It's just going to have a few slight changes, mostly at the end. So first, we have to start by checking that this system of equations can be solved by counting first the number of equations, 1 and 2. So let's write it down, 2 equations. Now we got to count the number of variables. And let's start with the y's. Remember, even though they are 2 y's, they count as only 1. They are the same variable. So that's 1 variable. And same with the x's. Even though we have 2 x's and even though they have different exponents, they're still the same variable, so 2 variables. 1 y, 1 x. So 2 variables. The number of equations is greater or equal, in this case equals to the number of variables. So that means yes, we can solve. Let's proceed and let's solve this using the substitution method. Let's first learn the substitution method. We know for the substitution method, let's put this horizontally because, well, we need the space. And we have to pick one of the 2 equations, and we have to solve for one of the 2 equations. Let's start with y minus x equals 5. It's recommended to start with the easiest equation, the equation that looks easier. Although, no matter which equation you pick, you will still get to the same solution. Now, we have to solve for one of the variables in this equation. Let's solve for y. We can solve for either one, but let's solve for y. And to solve for y, we got to move this negative x to the other side. So we do the inverse operation, which is a positive x. The x's cancel, but if we do it on one side, we have to do it on the other. Then 5 plus x, y equals 5 plus x. We can't really do 5 plus x, so we just write as 5 plus x. And now that our variable is isolated, y has been isolated, we can write this as equation 1. We can label it, so we can use it as reference. We solve for one of the equations, we have to move on to the second equation, y minus x squared equals 3. And remember, we just solved for y. We just know this y in the second equation is the same y that we just solved for in equation 1. And we just figure out that that y is equal to 5 plus x. And as the name says, this is the substitution method. We have to substitute the equation for y. So instead of writing y, we're going to replace it for this 5x. And we get 5 plus x minus x squared. So we did the replacement. Why do we do the replacement? Because now we have an equation with just x's. So we can solve for x. Now what do we do? Well, first of all, that parenthesis, it doesn't have anything to the left. So when a parenthesis only has a positive, like just a positive or a positive 1, or nothing, like in this case, we can just delete the parentheses. So let's do it. And we get 5 plus x minus x squared equals 3. This is a quadratic equation. We still haven't learned how to solve them. We're actually going to learn how to solve quadratic equations in Unit 7. But the important thing is quadratic equations, they have 2 solutions. X equals 2. X equals -1. Yes, quadratic equations are going to have 2 solutions, as we're going to learn. And this is where it changes the nonlinear from the linear system of equations. Sometimes, actually most of the times, we're going to get more than one different solution. So we have 2 values of x as the answer. Let's pick one of them. Let's start with x equals 2. And well, we have an equation of y including x, an equation of y in terms of x. So let's replace it. It's the substitution method. Let's substitute it. We now have a value of x, which we know is 2. Let's replace it here for x. If we do that, we get that y is equal to 5 plus 2, and 5 plus 2 is just 7, so y equals 7. When we choose x equals 2, we got y equals 7. But x equals 2 was not the only solution. We had another solution, so let's bring back the x. And let's take care of the other solution, which is x equals -1. One more time, we have an equation of y in terms of x. So we replace now the -1 into the equation, which gives us 5 plus minus 1. Well, plus minus, that simply means minus. So 5 minus 1. We can read this as 5 minus 1. And 5 minus 1 equals 4. There we go. We have our solutions. Now let's bring back the x just so the equation looks as it was. And now what are the answers? We have so many numbers on the screen. We just have to group them. When we picked x equals 2, we got y equals 7. So that's a solution. And we write it as a coordinate point, 2, 7. The x coordinate goes first. The y coordinate goes second. When we picked x equals -1, we got y equals 4. So this is our second solution, -1, 4. These are points in a coordinate system. And these are the two solutions to our nonlinear system of equations.